Welcome back to MOVI-C Control Cabinet Products Basic to Intermediate Training. This is session 14 and lab number 6. We're moving up to the intermediate concepts now by working with MOVIKITs, and we're going to start with the Velocity Control MOVIKIT. This is one of the MOVIKITs that is free with all levels of MOVIDrive technology, and it's also free with the controller level MOVIKITs for MOVIDrive System and MOVIDrive Modular. It's very easy to set up, it's very powerful, and it allows you to do some very useful things. Before we get into the pre-lab instructions, let's take a quick look at motors. This lab works with either motor type, an asynchronous motor or a servo motor. If you have an asynchronous motor, be sure it's still set up as lab 3 specified, that is VFC plus mode. If you have an asynchronous motor only, I'm guessing that you skipped the ELSM mode and the last thing you did was the ramps and stops. Your motor should still be set up correctly. Just be sure it's in VFC plus mode and you're good. If you have a servo motor, it should be set up as lab 5 specified. That was the ELSM setup lab, the last one we did. You should still be in good shape if you were in that lab last. I'm going to be using a servo motor. In fact, I'm going to be using a servo for the remaining labs because it's really a better choice. Most of them are more advanced. Servo motors let you do a few things more easily than asynchronous, although you definitely can use an asynchronous motor for many of those labs too. I'll be specifying that as we go along. Now, just some brief pre-lab instructions, not much here. Want to overview how we install a MOVIKIT and some of the changes that happen when you put one in. Adding a MOVIKIT to the Axis adds a new menu group to support it. So with drive level MOVIKITs, you add them to the bottom of the Axis circle by clicking it and picking the MOVIKIT from a list. Then when you go to the menus, you're going to discover that there are some new ones added by the MOVIKIT. Interestingly, some of them are actually duplicates of existing menus, sometimes pared down with just fewer options in them. You can use either version. Some, however, are specific to the MOVIKIT, and you can explore those. We will certainly look into them when we do the lab. And there's a very important tool, and that is called MOVIKIT Diagnostics. This allows you to simulate a PLC without having one actually connected up. This is a goldmine for testing. You can test the MOVIKIT completely using just MOVISUITE, and then later, if you're not a PLC person, you can hand the VFD off to a PLC person who can write the required code and send the process data words that control the MOVIKIT. It's really pretty elegant, and I think you'll be impressed as you see it. All right, pause the video and do the lab. Okay, hope you found that interesting and useful and are impressed by what you can do with MOVIKITs. Let's do the lab walkthrough and you can see me go through it and explore the MOVIKIT. All right, well, we're going to play with the MOVIKIT now. We're going to add the Velocity Control Drive Level MOVIKIT to our VFD and give it a try. I'm still in ELSM mode with my encoderless servo, or what's simulating one. The Velocity Control MOVIKIT can run open loop, which means it can pretty much run on every single motor that the VFD supports. So let's go ahead and get started. To add a drive level MOVIKIT to the Axis, we just click on the lower part of the Axis circle where it says Add Software Module. And if we click that, we get a list of the MOVIKITs that are available. Now we do need to be careful to pick drive level ones since we're working with the MOVIDrive technology. If we were working with a MOVIDrive system or modular, we would be able to use controller level ones, but we don't have that here. So I'm going to pick Velocity's drive, click it, and pick Add, and that's going to put it on the Axis. Now, when you add a MOVIKIT, it usually gives you a warning that it's going to make a bunch of changes, and it asks you for your OK, and I'll say yes, that's great. And there we go, it's added the MOVIKIT. You can tell there's a MOVIKIT there because the symbol changes to the little picture associated with the particular MOVIKIT. By the way, to remove a MOVIKIT, you can simply right-click on the lower part of the Axis circle and pick Delete. That's how you get rid of them. I would also like to mention that sometimes in certain versions of MOVISUITE, I think there's a bug or something, because when you click here to add one, nothing happens. So remember, you can always right-click and pick Add from Catalog instead. That will also allow you to add the MOVIKIT. So that's an alternative way if just clicking on the lower part doesn't work. All right, so we've added the MOVIKIT. It's successfully attached itself because its symbol has appeared. Now we need to move on and configure it. Before we do that, however, you notice we've got a fault. That is very common for a fault to appear after attaching a MOVIKIT because parameters have changed. So I'm just going to click here on the red lightning bolt, and it just says Process Data Configuration, Changed Process Data. Big surprise, we did do some changes, so let's just reset it. Okay, everything's back to normal. Now we're ready to configure the MOVIKIT. We need to get to our menus, and we can click anywhere that takes us there, but I'm going to just go ahead and click on the lower part of the axis circle because that takes us to the section of menus associated with the MOVIKIT. Notice we've selected our new menus, which have magically appeared, MOVIKIT Velocity Drive. Notice we have a bunch of new menu choices, although some of them are duplicates of menus above. All right, so we need to configure our MOVIKIT by going into some of these menus here. We're going to start by telling it where to get its control instructions, which is over the field bus card normally. So we're on basic settings already. That's where we need to be. We need to pick the basic settings menu under MOVIKIT Velocity Drive, and then we need to go up here to our source and change this to field bus. That way it's going to listen to the field bus card, and if we had a PLC connected up, it would be responding to it. Now, this is something we have to do because we're in an open loop control mode. If we had an encoder, a closed loop control mode, we wouldn't need to do this step, but in open loop mode, the system doesn't know the motor's exact speed because it has no direct feedback. It sort of estimates it by measuring motor current, and it also knows, of course, how it's pulsing, the pulse width modulation. But we need to activate kind of a safety feature here that we use in open loop modes, and we're going to use this since we're in ELSM mode. If you were in VF mode, you should also use this. That, of course, would be with an asynchronous motor. We need to go to the Drive Functions menu here, and we need to turn on this switch, FCB05 Speed Control. We need to activate this. What this does is it defines 160 RPM and below as the speed at which the VFD will consider the drive stopped. This essentially helps the VFD to make decisions about using the brake. All right, if you have an encoder, you don't need to activate this, but if you're open loop, you do. All right, moving on. We now need to configure the I/O because the MOVIKIT can use it in several different ways depending how we set it up. So I'm going to click Inputs and Outputs down here. And first of all, I'm going to change the default assignment to freely configurable. That means I can individually configure every bit. Now, if they're anything other than what they are, I need to change all the digital inputs to no function. That means that the MOVIKIT will have full access to them. They're already set to no function, so I don't have to do anything. I do, however, need to go ahead and configure my DOs so that they can be controlled by the MOVIKIT over the field bus. So I'm going to change DO00 through DO03 to control via field bus. And by doing this, the field bus will be able to control them, and I'll be able to send process data words to manipulate the outputs. This is actually a handy way to get some extra IOs if, for example, your PLC is a bit IO starved. Remember, you can access the inputs and the outputs on the MOVIDrive technology over the field bus. That is handy. Okay, so we're now configured correctly on the I/O front. We're now going to move on, and we're going to go to the field bus interface, and we get to pick an option here. You may remember in our last session when I talked about the POs and PIs and what they do in 5PD mode, that I said that PI4 can report back a user configurable parameter. Well, this is the place where you pick that parameter that it sends back as feedback to the PLC. Right now, notice it defaults to torque in percentage of nominal motor torque. That is okay if you want that, but I'm going to pick instead relative current in percentage of nominal device current. That way I can get an idea what percentage of current I'm pulling as the motor runs. There is a third choice there, by the way. You can also send absolute current in amperes if you want that instead. So there are 3 choices for PI4. Now, the last thing we have to do is set the field bus IP address. We're going to go ahead and do some changes there. Now we move out of the MOVIKIT Velocity Drive menu and we go back to the Device Properties menu and pick Communication. And I then pick Field Bus, and I need to set the IP address. Now, here's the section you change right here where it says Address Settings. By default, the MOVI technology activates DHCP. That's the Domain Host Control Protocol, where the VFD can just go out and get an IP address from a DHCP server. You may use that in your installation, but for this activity and for many setups, you want to use a static IP address, one that you hard code in. So we're going to do this, and we're going to change it to the SEW Eurodrive default hard-coded address, which is 192.168.10.4. To do this, I need to pop this down and change this to saved IP address parameters, and I need to go up here now and key in my IP address, tabbing between fields, except when I get to the last one when I have to hit Enter. So I'm going to take care of that right now. 192.168.10.4. I'm going to set my subnet mask to 255.255.255.0, and I'm going to set my default gateway to 192.168.10.1, and I'm not going to tab, I'm going to hit Enter. If you don't hit Enter, if you tab, you can actually cause your drive to fault, and the way to clear that is simply to turn it on and off, and it will clear. All right, I'm going to also click Apply Address Settings, and there we go. Our IP address is now set, and if we plugged into the Ethernet port on the front of the field bus card with, for example, a PLC or even a PC running a PLC simulator, we could access the VFD. Now, I've got a fault again here, so I better deal with that. Okay, again, it's just that I've made some changes. Fine, let's reset that, get rid of that. And now we're back to 01, which means controller inhibit, means we're ready to run. All right, so now we're ready to run the access, and we're going to do that using a really nifty tool built into MOVISUITE called the MOVIKIT Diagnostics tool. It's under the Diagnostics group. I just click that, and up this comes. Let me tell you a little bit about this tool. It's actually 2 tools in one. By default, it's a monitor. It's going to show you everything that comes over the field bus from an external PLC, and it's going to tell you what it's sending back over the field bus through the PIs. So if you're trying to set up communications with a PLC, open the Diagnostics tool. It's really a great tool because it can show you that you're communicating with the PLC. You can see that data is arriving in from the PLC. You can see what you're sending back. It's a great troubleshooting tool. However, we're going to use it in its second mode today, and that's where it simulates a PLC. So we don't need to be a PLC programmer or have a PLC handy. We can just check that the MOVIKIT is working right here in simulation mode. Now to do this, we need to do a couple things. I need to remove controller inhibit from my drive. So I'm going to turn my DI00 switch on my control box on just to get that out of the way. And now I'm ready to go. I'm going to click the Activate button to go into simulation mode. So now I'm a PLC, and I'm controlling the MOVIKIT exactly as if I were a real PLC sitting out there talking over the field bus. All right, so what we need to do now is manipulate the POs, because that's what a PLC would be doing. It would be sending those 5 POs, PO1 through PO5. Let me point these out. Okay, here are the POs right here, PO1 through PO5. Notice they're labeled what they do. The first one's the control word. That means it has lots of bits that turn things on and off. PO2 is the speed to run the drive. PO3 and 4 are the up and down ramps, and PO5 controls the digital outputs. I also have the individual bits broken out on PO1 right here. They're actually little toggle switches I can flip, and they're all labeled very conveniently, so I know what they do. And what it shows up here is the hexadecimal equivalent of those switch positions. And if you don't know what hexadecimal is, it's an alternative numbering system that programmers often use because it corresponds to binary numbers really neatly. All right, so we're going to run the drive. And so to do this, I'm going to simply type in some speeds and ramps. I'm going to give a speed of 2000 RPM. And remember, I've got to hit enter. I'm going to put in some ramp values here. I'll use acceleration of 9,000 RPM per second, and I'll use a deceleration of the much slower 500 RPM per second. All right, now the drive isn't doing anything, as you can see. That's because I need to manipulate the control word. I've got to flip some bits to make things happen. So let me show you the bits I need to flip here. First of all, I have a software equivalent of controller inhibit right here. It's called activate output stage inhibit. It's turned on. That inhibits the drive, so I need to turn that off. All right, and that removes controller inhibit. Now I need to enable the drive, and there are two enable switches. There are two bits in this word that enable the drive. So I need to turn this on, and that will enable the drive. Notice one is called the enable emergency stop and the other enable application stop. That lets me activate either of my two stop ramps, the emergency stop ramp or the application stop, just by removing that bit, turning it off. Of course, if I turn bit 13, activate output stage inhibit, it will do a software equivalent of the controller inhibit switch. Now the drive still isn't turning. You may wonder why not. Well, I've got to tell it. Go ahead and start running with the start stop with field bus ramp. So I flip the switch and bingo, our motor is running. And I can stop it just by taking that bit off. And it's going to decelerate at that rather slow ramp because it's using the ramps that I provided in PO3 and PO4. Okay, looks like it's working pretty neat. That's really all there is to basic velocity control. Let me start up the drive again, point out a few things. First of all, notice we have this nice little speedometer that tells me what my speeds are. Notice also I've got my PIs coming back. That's the status from the VFD. And PI2 is the actual speed, and notice it's about 2,000 RPM. Of course, it's moving around a little bit. It's providing status information. It's telling me how much current my motor is pulling. It's 1.6% of its nominal current. That's because I have an unloaded motor. And it's also showing me my digital input values. And right now you can see the controller inhibit bit turned on and everything else turned off. So lots of good information here. Okay, I'm going to stop my drive again. And again, it ramps down pretty slowly. Now we're going to play with a few things here. I'm going to start my drive, and it's at 2,000 RPM, and I can just change the speed without stopping it just by changing PO2. I'll change it to counterclockwise 1,000 RPM by putting in a minus 1,000, and the drive decelerates and reaccelerates in the other direction. You can change POs as the drive is running. Of course, you always want to be thoughtful about doing that to not do anything dumb, but you can definitely do that, and that's what your PLC would normally do. Now let's play with our different control bits. Let's do an emergency stop by clicking bit 0 off. Notice that does a pretty quick stop. I'll resume the drive, and I'll do an application stop by removing the other bit. That was about the same speed. I think my application stop and emergency stop are currently set pretty close to the same value. I'll start my drive up again, and I'll do a controller inhibit stop, and you'll see a really quick stop here. And the brake clicked on very smartly too, because again, remember that's an uncontrolled stop, and I do have a brake on this drive. So there we go. And what you might want to do is back up the video and look at PI1 through PI5 just to see the status information it's reporting as I did those things. So you might want to take a look at that just out of interest. Let me point something else out. This will make more sense to you if you're a PLC programmer. As you can see, we do a lot of our control work by manipulating individual bits in PO1. Now, if you're really good with binary and hexadecimal, you can work this out on paper and probably even convert it in your head. But if you're new to this and you want to know what the hexadecimal values are for different things, let me show you a shortcut. If you go up to PO1 control word, it's showing the hexadecimal equivalent of the current switch settings. So to run the drive, if I send hexadecimal 83 from my PLC, that's the equivalent of these switch positions. And I can work out all my hexadecimal values just by flipping the switches and jotting down the numbers. For example, to do an emergency stop, I would send hexadecimal 82. To do an application stop, I would do hexadecimal 81. To stop the drive with the normal field bus ramp, I would send 0003. So just something handy to think about, that we actually are showing you the hexadecimal codes as well as the binary through the diagnostic tool. Pretty nice. I've already pointed out that we can read the inputs and control the outputs over the field bus, and you can see my inputs. Let me just flip a few switches on my box and you'll see those bits changing here in PI5. Let me do that. I've just turned on all 8 switches on my control box, and you can see all those bits went to 1. So my PLC could take advantage of that if it cared. Okay, I'll take those away. If I want to turn on the lights on my control box, I can type in bits right here in PO5. For example, if I put a 1 bit right here and hit enter, that turns on DO00 on my control box. Now you can't see my control box, but I assure you I'm looking at it and it's lit up. Let's turn that off. And it just went off. So that's pretty good. Let's stop the drive. And we're going to make a few changes here. First of all, we're going to put the drive in a safe state by turning the enables off. We're going to turn the controller inhibit switch back on. And we're going to flip the hardware controller inhibit off as well. And now we're going to release control back to the field bus. So I'm going to shut down the diagnostic tool because I'm going to make a change to my system and I can't do it when the tool's active. So I click deactivate and say yes, deactivate PC control. We're just back to plain old monitor mode now. And we're going to do just one final thing. We're going to set up some hardware limit switches as a safety feature. So we're going to use DI02 and DI03 as limit switches. Now, since limit switches are active low, I better turn those 2 switches on or my drive is going to fault the minute I assign them to that function. So I have taken care of that now. I'm now going to go to MOVIKIT Velocity Drive Inputs and Outputs. And I've left my individual bits freely configurable so I can assign them to specific functions here. Notice DI2 and 3 are both showing on. That's good. I'm now going to pop these down and assign them to hardware limit switch positive and negative on drivetrain 1. So now this is going to be a protective function, and if either of those switches off, it will fault the drive and halt it. Let's go back to the diagnostic tool and test this out. I'm going to take control again in simulation mode. I'm going to turn my hardware controller inhibit switch on, and I'm going to start the drive running. And I'm going to do just what I did before. I'm going to run it at 2000 RPM. Remove my software controller inhibit, enable my drive, both bits, start it up with the field bus ramp. We're now spinning along happily at 2000 RPM, and now I'm going to triple limit switch by turning DI03 off. And there we have a fault. And you can see the fault popped up here. My drive stopped. Notice that there is a fault bit that goes back in PI1. By the way, this is PI1, all the individual bits. That's a status word. And you can see there's a fault bit telling us what happened. There's also some extra information here. So take a look at that as well. So all this is information your PLC can use. It can also do something really nice. It can clear the fault in software. So I'm going to turn the limit switch back on first. And I'm going to show you a very handy little bit here, bit 8 in PO1, fault reset. I'm going to just turn this on and then off again. That's the software equivalent of a hardware fault reset switch. So there we go. Again, PLC can do that as well. Pretty neat. This is really a powerful tool, and as you saw, it took very little time to set it up and confirm that it was working. So let's stop it, shut everything down, turn our controller inhibit, both software and hardware, into the safe state, and finally release control of the access by deactivating and saying yes. So there we go. Velocity Drive MOVIKIT in about 25 minutes. And that is the end of session 14. I hope you are getting comfortable with the MOVI-C line and realizing how well SEW Eurodrive has engineered it to handle so many applications through the use of tools like MOVIKITs. See you in the next session.